So now in this video we're going to look at using the 747 dual op amp, and we have here a rail splitter circuit for one of the op amps, and then the other op amp will be, we'll either call it a voltage follower or a unity gain amplifier. Basically we'll set the voltage that we want to the non-inverting pin, and the inverting pin will have be connected to the output of the op amp, and it will output the same voltage but be able to provide more current than what the trim pot can provide. It will not depend on the current of the trim pot, only the voltage. So in any case, you can see here the jumper comes up here. This is the inverting pin for this op amp and the output. So top pin on the left for the inverting input, and third pin down to the right for the output. And then this jumper just extends where the output goes. Now you'll notice this is a mirror image down here. We have the inverting input right there at the bottom, and so it moves over and then goes up up two more rows, I should say, to the third pin for the output of that op amp. So this one's third from the bottom, that one's third from the top. So they're mirror images. Also, they share a negative voltage, but each one of them is independently powered with the positive voltage. So that's second pin up for that one, and then this one's second pin down for that one. Now these resistors are 1 kilo ohm resistors, so we're setting the ground to a halfway point between the positive and negative rail, and we easily do that with a 100 kilo ohm resistor from the negative rail to the non-inverting input, and a 100 kilo ohm resistor, exact same resistance, going from the positive rail to the non-inverting input. That will give us half the voltage. So that will be 0 volts, our virtual ground, as far as we are concerned. So for this circuit, as the voltage follower, we just have to add one more thing now, and it'd be a little distracting earlier, so I held off plugging in. So we got a jumper there. We're going to go up 2 rows to the, so this is the inverting pin up here to the non-inverting pin, and that's it. So one nice thing though would be to add a couple LEDs. So first we'll get the protective resistor. This is a 1 kilo ohm resistor, 1000 ohm resistor, and we're going to put it so that it's 1 square down from the top of that jumper, and then we're going to put the other end to the output of the op amp, the lower op amp right there, and bend it like that. So now you can see it. So it's 1 row down. As I said before, this jumper just extends the output of that op amp. Now we're going to use green and red LEDs. I do this a lot. The green one I want to light up when the output is more negative than our 0 volt reference point. So the short lead, the cathode, is going to go to the resistor. Long lead, the anode, is going to go up to our virtual ground right there. And the red LED, we want the opposite. We want it to light up when the output is more positive. So the long lead, the anode, is going to go towards the output there, but connect to the resistor. That will limit current. Short lead, the cathode, is going to go up to our virtual ground right there. And I'm having some issues with the trim pot, but hopefully it will behave pretty well. You can see that we have these coming from my bench power supply. It has alligator clips. I crimped these other alligator clips to these jumper wires so I can plug them into the board, and then I have these other jumpers that push the power to the other rail. And so I'll turn it on, and neither LED is lit up right now, but we're at about the halfway point. So as far as the LEDs are concerned, it's close to 0, and it's not enough for their forward voltage to start lighting up. So now I'm turning it more positive. You can see the red LED is starting to light up, so it's probably about 1.6 volts or something, and I keep turning it up. The output's probably not going all the way to the rails, but we're pretty close. So I bet that's about 7 volts or so. Now I'll go down and the LED will turn off. Now I turn it towards the negative rail, the green LED starts lighting up. And again, we probably won't get all the way to the rail, but that's probably about negative 7 volts now at the output. And then, so since we're going to the virtual ground, that's just kind of the switch in the board not working perfectly. So let's get some multimeter measurements and see the actual numbers on the multimeter screen right there. So as I said, bench power supply is set to 18 volts. I just put it a spec above 18 volts, and so actually I had those backwards, so it was negative, but no big deal. So 18 volts right there. Our output right here is at 8.10 as far as that is concerned, but our actual ground now is going to be over here. And so now you'll see we have 9 volts positive at that rail and then negative 9 volts at that rail. And so we got about negative 0.1 at the trim pot there. And we have the same voltage over there. So it's a voltage follower. We have the same voltage. So now let's turn this a little more, get the LED up. And again, we have some problems because of the board and the switch. But there you can see negative 3.2, so plenty to get the LED to light up. And this is a 10 kilo ohm resistor, so it would not be as bright if I tried to just light it directly from the trim pot. The trim pot would really struggle to give it enough current until we get really close to the rail, and then we give it too much current actually. But this is just setting the voltage. Actually it won't, because we'd still have a limiting resistor. But in any case, negative 3.2, and there's negative 3.2. Let's see what our rail limit is. So there we go. I got it so that we should have about negative 9 volts at the output. There at the trim pot output. Now for the op amp output. There you can see it's about 2.5 volts, a little bit more even, away. So it doesn't go all the way to the rail. So you have to work within its limitations, which are closer to 0 volts than the rail for this particular voltage. And the lower the voltage, the farther it's going to be from the rail. It's probably going to be about the same actual volts. So the more voltage you're working with, the more range you'll have. So in any case, that's 9 volts. Yeah, that's all the way to the rail. So I didn't mean to go all the way to the rail, but let's see what we're actually, that's 9 volts, see what we're actually getting. So 8 volts. It's doing a little bit better towards the positive rail with this setup. Let's go down a little bit. I was going to do this one first, so LED's not as bright. Oops. So about 6.16, and I think it will actually show that. It's getting kind of close to the rail. Alright, doesn't look like it's doing as well, but we're getting closer to the rail, so turn it down a little bit. So hopefully that all makes sense. There we go, 3.9, so just a speck below 4, and there again. So it's not holding as steady, but it's still really close. We can set the voltage and have about the same voltage at the output pretty reliably. So that is a voltage follower, or a unity gain amplifier, however you want to call it. Those really mean about the same thing. We have the voltage that we set, but we don't have to worry about the voltage source being able to provide the power for whatever reason. So in this case, we're using a trim pot, a 10,000 ohm trim pot. We're only using a 1 kilo ohm resistor to set the current based on the voltage coming. And so this low resistance, if that went directly from the trim pot to ground, it would really lower the voltage from whichever way you're trying to send it. You'll have less voltage, either positive or negative. But we'd use an op amp that takes the resistance that this has, the impedance, out of the equation. There's very high resistance impedance at the input, but it measures the voltage. It looks at the voltage. And then with the negative feedback here, it makes sure that it holds that voltage pretty well and outputs whatever current it needs, as long as it can output that much current. So there are limitations, but the main takeaway is that the voltage in is the voltage out. And so thanks for watching. I will see you in the next video.